Okay, so hey everyone, today we'll be discussing the problem maximum points in an archery competition. So this is a medium level question, so let's just directly get into the question. I'll be explaining the question via a example given in the Leetcode section. You can also read the question. I'll add the link in the description. So the question is, in the question we are given Alice's arrow. So basically this is more like a archery set, like the bullseye kind of thing, where you have a total of 11 ranges. Like for example, it's something like this. So this has 0 point, this has 1 point, this has 2 point till 11. So Alice already has completed the arrow competition, and in the zero section, like from where we get 0 points, she has marked one arrow. In the section where we get 1 point, she was able to get one arrow in that section. In the section where we get 3 points, she was able to get one arrow over there, and similarly for 6, 9, 10, and 7. So this part has already happened. So if you see, Alice has already is done with the competition. Now it's Bob's turn. So Bob is not yet done with the competition, but he is given some number of arrows. This is the number of arrows that he has been given. That is a total of 9. And we have to tell like this. This is the thing that we have to return. Like we have to tell what is the optimal condition for Bob to hit which target. Like if you see, the sum of these arrows is a total of 9. So if I say Bob has hit 3 arrows on the 10 section, like the section which gives you 10 points, he has hit 2 arrows in the section which give you 9 points, and this was the optimal condition. So suppose this is, let's consider this one, the 10 section. So now we have to give points to one of those. Like who will be winning the 10 sections? So Alice, as you can see, she has hit 2 points and Bob has hit 3 points, like 3 arrows, and Alice has hit 2 arrows. So Bob here will be the winner. So over here, Bob will get 3 points. Up here, you can see Bob was able to hit 2 only, and like 0, and Alice was able to hit 2 arrows. So 6 points goes to Alice. So that is how we compare for a particular section, like the particular marks, like whatever marks that section has. You have to check who has hit the most number of arrows, and the one who has hit the most number of arrows, the points will directly go to that person. So as you can see, Bob was able to get this point. He was not able to get this point because here Alice has hit 2 points, like 2 arrows, and Bob has hit 0 arrows. Similarly, Bob was not able to get these 2 points as Bob here has hit 0 arrows and Alice has hit 1 arrow. Bob was able to get this because here he has hit 1 arrow, Alice has hit 0. Similarly, 9 because 2 is greater than 1. Similarly, 10 because 3 is greater than 2 and 1 is greater than 0, 11. So if we sum this up, we have a total of 47 points. So this is the question. So you have to return this. What is this? This is actually this array, this one, this array. This is what you have to return: 0, 0, 0, 1, 1, 0, 0. Like this is basically this array, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So at the 11th section, it's optimal for Bob to hit one arrow, and the sum of these arrows should not exceed number of arrows because that is the number of arrows you have. So you cannot exceed that. So this was the question. So we have to give this array Bob's arrow, and we have to make sure that this marks is maximal, that this point is 47. So if you see any other combination, like you can't get a higher score than 47. This is the maximum. So now let's understand the next part of this question. So the next part is why some arrows will be always left out after getting the maximum answer. So and where to accommodate them. So let's just consider example. So I'll just make that table again. 4, 5, 6, 7, 8, 9, 10, 11. So suppose the Alice array that we have been given is something like 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and 1. So Alice has already hit a single, like for every target she has hit one arrow. So now it's Bob's turn, and Bob, let's just say he has a total of 20 arrows. Okay, he has a total of 20 arrows. In the test case given, he has a total of 20 arrows. So Bob will, so what is optimal for Bob? To get a score at everything, so he can hit 2 over here. It's not needed because anyways he'll get 0, but let's just say he'll hit 2 arrows in the 0 section. Again, everywhere he'll be hitting 2. So if he'll hit everywhere 2, what is the total marks, what is the total score that he'll be getting? He'll be getting 0 plus 1 plus 2 till 11. Like this will be his total score. That is basically 11 into 11 plus 1 by 2. Like this will be his maximum score. You cannot get, like, cannot get a score higher than this. So what will be the answer? 11 into 12. So that is 132. This is the maximum score that he'll be getting. One second. Yeah, so this is the maximum score that he'll be getting. And how many arrows did he waste? He wasted, okay, sorry. Let's just assume he has a total of 30 arrows. Okay, he has a total of 30 arrows. So how many arrows did he waste? He wasted 2 into 12 into 2 into 12, 24 arrows he wasted. But still, if you see, he has 6 arrows left. So someone will say add an arrow over here. So it's no point, right? Anyways, 2 is higher than 1. You are getting 11 points if you hit 2 arrows. 11 point if you like, you will be getting 11 points if you hit 2 arrows because 2 is greater than 1. You will be again getting 11 points only if you hit 3 arrows because 3 is also greater than 1, right? So it's no point in adding arrows. So if you have any arrows left after fulfilling the maximum answer, if you have any arrows left, you can just add it anywhere. Like I can just make this 8. I can make this like any one of them you can make it. It will not make a difference because it won't get you extra points. You have already exceeded the number of arrows that was hit by Alice. So that thing, so it's like there you won't be getting bonus points for hitting more arrows than Alice. Like only you have to exceed one. Like if Alice has hit one, you just need to hit two. You just have to suffice this condition, and that is fine. Like no more arrow. Like it's not needed to hit 10 arrows, like 9 arrows more than Alice. You just need to be higher than Alice. So the minimum one is Alice plus one only always. So yeah, this was the small case, like what if there are more arrows? If there are more arrows, after the minimum number of arrows to get a maximum score, after getting a maximum score, you just have to just add it anywhere. It won't make a difference. So now how will we solve this question? So the important part for this question was that 12 thing. You only have 12, like you only have 12 targets, like the bullseye, the radius is 12 or whatever you want. You can say it's a total till 11 only. So looking at this constraint, we have an idea that we can use bit masking, like we can traverse through the bits. So why do we need a traversal or bit masking? So suppose you have this 3 4 5 6. So if I just go back to this slide, okay, if I just go back to this slide, if you say the optimal answer you got was by targeting the fourth one. You got score for the fourth one, right? Fourth one, fifth one, you got a score for fifth one also. Then you got a score for the eighth one, ninth one, 10th one, and the 11th one. So this was the substructure, this was the mask that was giving you the optimal answer. So now if we see this bitwise, so 8 9 10 11, so that was 4 5 8 9 11, right? So that is 4 5. I'm just marking one, like which target, like which section we targeted to get our highest point. So we made sure that we 4 5 8 9 10 11, 4 5 8 9 10 11, and rest all we didn't even care about. Like we only wanted to win in these sections. This was our target. We only wanted to win in this section and we wanted to grab the points of these section. That we said that no matter what, I want to get this point. So if I want to get this point, so even if Alice in the ninth section say has 3 arrows, I have to get 4. So this was the mask. Sorry, so this was the mask. This was the mask that gave us the maximum answer. This was the mask that gave us the maximum answer because we were targeting only these sections. Like we said, Alice, that no matter what, I'll win against you in these sections 4, 5, 8, 9, 10, and 11. So this was a target section. So to get this target section, you have to run a subset traversal because you won't know this, right? There isn't a greedy method that you can use because So someone will say that it's okay if we get 11. So what if you get 11 and Alice has 3, 4, 5, 6? You lose, right? There's so greedy method would work over here. So now let's see how subset traversal works. So suppose, let's just say, I'll show you with a smaller range. Suppose you only have 0, 1, 2, 3, 4. Okay, and you want to run a mask on this. So it's okay if you run I is equals to 1. So what is the maximum condition? Like you hit all these. So this is 2 raised to 4, right? 2 raised to 0, 1, 2, 3, 4. This is 2 raised to 4. So now you have to traverse from I equals 1 till I less than 2 raised to 4. This is your demo. So if you do this, what will be, so what is I equals 1? I equals 1 is 0. I'll just write it in the form of bit 0, 1, 2. Okay, so let's just say this way 0, 1, 2, 3, 4. I equals 1 is this 1, 0, 0, 0, 0. What will be I equals to? It will be 1, 0, 0, 0, 0. What will be I equals 3? It would be 1, 1, 0, 0, 0. And similarly, you will be going on till 1, 1, 1, 1, 1. Oh, I think we'll have to go till 2 raised to 5. Yeah, you have to go till 2 raised to 5 because 2 raised to 5 is 1, 0, 0, 0, 0, 0, and you have to traverse till this part only. So I from 1 to I less than 2 raised to 5, like from 1 to 2 raised to 5, and this will be basically covering all the subsets. Similarly, but now you have to actually run from I equals 1 to I less than 2 raised to 12. This is what you will have to run, and you will be covering all the possible subsets. Like over 4 you saw, I'll be, if I draw all these, you'll be covering all the subsets. So let's just make this for I equals 1 to I less than 2 raised to 3. Okay, so it is 1, 2, 3, 4, 5, 6, 7. So for 1, if we write it's 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So if you see all the subsets of 3 size, all the subsets of 3 size are covered over here. There is no subset remaining. Except 0, 0, 0, you won't ever get that condition. Except 0, 0, 0, all these possible subsets are covered. So instead of 3, we'll be running this for 12. Instead of 3, we'll be running this for 12, and you will be generating all the possible subsets. And even if you check, 2 raised to 12 is a very, like, not that of a great number, so it won't ever exceed your, I think 2 raised to 12 is 1024, or I'm not sure, but it will never exceed, like, uh it will never exceed the time limit. Like it won't be 10 raised to 9 or something like that. I'm not sure about 1024, but it will never exceed that. So yeah, this was the whole part. Like I told over here that only the subset matters, and in this case the subset was 4, 5, 8, 9, 10, 11. So you have to get the correct subset, and to get the correct subset you have to iterate over all the subsets, and that you can do in 2 raised to n complexity. This is how, so this is the time that you'll be taking to traverse all the subsets. So now let's get to the code part, like the final, like what will be the code for this. So you, if you see the, if you see the output, we actually have to give the this array. So for, if you have the correct mask, this is very easy to get. Like if you have the correct mask, like if I would have told you that the mask for this question is 1 second, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I would have told you that the mask for this question is 11, so if I would have told you this is the correct mask, like if you would have got the correct mask, and I would have told you like this is the mask that you want, like this is the mask that you are aiming for, so then it is very simple for you, because you know that this is a valid mask and I have to beat Alice in this mask. So you will only go, so you will check that, okay, 4 is set. Let me check what is the score of Alice. Suppose if Alice's score is X, let me just put X plus 1 and move on. Then I will again come to 5. Okay, Alice has 5 arrows in the 5 arrows in the fifth section, I just have to put y plus 1 and then move on. Similarly for 8, 9, 11. And this final mask should give you the maximum score, and it should not exceed the number of arrows needed. So that we have to check for every mask, that it is giving you the maximum answer and the number of arrows is not getting exceeded. So how to do that? So this will be the final mask and this will be the final score. Final score we have to maximize, and corresponding to that final mask we have to store even the final mask. Corresponding to that final score we have to save the final mask. So I'm iterating from I equals 1 to I less than 12. This is basically the subset traversal. You are traversing over all the subset. This is basically the subset traversal. For every mask you will be keeping a score for every mask. This will be for every mask, and for every mask you just have to reset the number of arrows. So you just come over here and reset how many arrows do you have. So it's given as, so you just have to reset. And wrong mask, this is just to check that if I'm saying that I'm targeting some mask, let's just say something 00101000, but I can never get. So suppose Alice has this mask. Okay, Alice has put over 5 arrows over here, you added 6. Okay, then say you only had 7 arrows with you, and Alice over in this mask she had a 7. So you can't put 8. You can never have this mask. You can never win over Alice if you consider this mask. So that time you have to make the you have to make that mask as wrong, like it is a wrong mask. It is a wrong mask, and then you have to not consider the mask. That mask is the wrong mask that you are considering. So now if you have the mask set, iterate over that mask, like whatever the mask you had of the 12 numbers, just iterate over that mask. And if it is set, like every mask will have different set, right? Like I showed you over here. Like showed you over here. For suppose if you have this mask, now you have to iterate over this mask. Like this mask says that if I am set, try to win this position. So what does this mean? This is saying that try to win, try to get this position, try to get this section, or win over Alice, try to get this section from Alice. If she has 0, like she has not even targeted section, then it's free. Like you can just target one arrow and it's yours. So try to get this section from Alice. So how many arrows do you need to win that section? Suppose let's just say we are talking about, so let's just say a trial mask. Okay. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's just say this is the mask. This is the mask. Okay. And this is Alice's score. Alice used 2 for this, 3 for this, 4 for this. Now this is Bob's. This is a trial mask. Okay, we are basically iterating over this mask. So this I just considered. Suppose we are in this mask. Suppose we are trying to make this mask as the maximum one. So you'll be iterating over this mask, and let's just say Alice has 2 over here. So what you have to do is you only have to get 3. So the arrows needed is Alice arrows j plus 1. You only need 3. You came over here, it is set, you need 4. Came over here, you need only 5. Basically you are targeting this mask right now. Okay, this is the target mask. This is the target mask. You want, like you are seeing what will be my maximum answer if I only target these 3 sections. After that is done, you check like how many arrows do I have. And so let's just see this as arrows. Number of arrows I have is greater than or equal to the arrows needed, is greater than or equal to the arrows needed. If that is the condition, just subtract arrows. Like obviously the number of arrows you possess will now get decreased, but your score will be increased. And what will be your score? It will simply that j, that will be your score. Else, if this condition fails anytime, if you are in a trial mask, and let's just say I had a 1 over here and Alice had 7 points over, you needed 8, but you suppose you only had 12. So this is the wrong mask. This cannot be your answer. This mask can never be your answer. That time, suppose this came right and I'm 8, and the arrows I had only was let's just say 12 only. All these 12 got over here. 12 minus 3, 9. 9 minus 4, 5. 5 minus 5, 0. Now, now the turn is I need 8 arrows. But arrows needed is 8. Arrows needed is 8. Arrows needed is 8. And the number of arrows I have is 0. So you will directly go into this thing. Wrong mask will be true, and you'll simply break because there's no point in iterating more, right? You'll go to the next mask. You will try considering the next mask. And after iterating over that mask, you will check if the mask is if wrong mask is still false and your score is greater than the final score, then just update the final score and make the final mask as this side. So basically this is we are iterating over here, right? And make this as the final mask. Make this as the final mask. After you got the final mask, how to generate the final answer? How to generate the final answer? You have stored the final mask, right? You have this as your answer. So let's just take a trial mask again. So 0 1 2 3 4 5 6 7 8 9 10 11. So let's just say okay, one second. So this was your correct mask. This was the mask that we calculated, and it is giving you the final score because we are sure, right? Because whenever we are getting a score greater than the final score, then only we are updating this. Then only we are updating the final score. So we are also sure that this final mask will give me the maximum score possible. Suppose this is your final mask. This is your final mask. Okay, now you have to generate the answer array. Now you have to generate the answer array, and you're also sure that the number of arrows will easily suffice these because you're sure because you checked. This mask was only satisfied when wrong mask was validated, right? You have validated this mask, so you don't have to check these conditions again. You are sure that you will all like this condition will always be true. You will always have that number of arrows because you have already checked that. So again, you have the mask, just iterate over that mask, check if that is set, check if suppose I'm here, check if this thing is set. Suppose Alice over here had, this is Alice array, okay? So Alice had, let's just say 3 arrows over here. So you know that you have to add 4 arrows over here, right? And also sum is initially the total number of arrows you had, and I'm just subtracting it from how many you are using. That like that will cover in this part. So I'm just subtracting it because you know that this 4 is correct. It will not fail again because you have already validated this mask. So suppose here we have 5, then you know you have to put 6 over here. You have 2 over here, you will put 3 in this mask. You have Alice hit 3 arrows in that target, you have to add 4 arrows over here. Alice hit 1 arrow, you have to put 2. So this is all the array you need. This is all the array you need. But suppose, so what is the total count? 4 plus 6, 10, 13, 17, 19. What if you had 21 arrows? What are you going to do with that 2 extra arrows? You can just add it anywhere. As I explained previously, just add it anywhere. So in this case, I'm adding it in answer 0. So just add 2 over here. So your final answer becomes 2, 0, 4. Sorry, this is also 0, this is also 0, you added a 0, 0. So you got right, this is basically the answer. So 2 0 0 4 0 6 0 3 0 4 0 2. So something like this will be your final answer. So in the end, you can just confirm if you are getting the final score by using the example test cases, and then you have to simply return this answer. This will be always true because you have validated it against all the conditions, right? So yeah, this was the explanation for this question. I'll add the complete code, like these were just bits and pieces. I'll add the complete code in the description. So yeah, thank you. Bye bye.